In this video, we're going to talk about polynomial equations, what they look like, what the different parts of it represent, and how we can classify them. So this is going to be a single term, or could be the sum of two or more terms that contain different variables with whole number exponents. So all these examples, we're going to have the variable x, that's our main base in all of our terms. And we've got some coefficient, a, b, c, etc. With exponents, you see just the value of n minus 1, n minus 2, all the way down to 2. This would be 1, and this would be like x to the power of 0. So that's just a constant. We can think of a basic example like y equals ax squared plus bx plus c. That's just standard form or general form for a quadratic function. And it looks kind of similar. It just has a lot less terms. So our coefficients have to be real numbers. Our a value, so the first term can't have a value of 0. Our exponents have to be non-negative integers, so could be 0 or positive, and they can't be fractions or decimals. The polynomials are going to be classified with a degree of n, or whatever the largest degree is. So in this case, it'd be a degree of 2. The leading coefficient is, again, that first number, or the first term that we've got that has the largest exponent. It's the number in front of that. And then we have a constant of m, or in this case c, whatever that term is that does not have our variable. So a little more vocab here and how we classify polynomials. We typically want to write our polynomials in general form, and that just means that the terms have to be written with the largest exponents first, and it's written in descending order. So, for example, x to the power of 2, x to the power of 1, and then our constant term that does not have an x has to be written in that order. The degree of a polynomial is based on that first term that has the largest exponent. Whatever that exponent is, that's the degree. The leading coefficient is then that number in front that we already mentioned. Sometimes you might just see the initials LC for leading coefficient. And then we can classify a polynomial based on how many terms it has. So if it just has one term, monomial; two terms, binomial, and etc. If it has more than 3, we can just classify it as a general polynomial. And just have, you can see the prefix for all these terms here are similar to other words that have that same prefix, so like bicycle, tricycle, polygon, etc. And make that connection with how many terms we have. So this example here would be a second degree with some leading coefficient a, and this is a trinomial because we have 3 terms. So a few examples here. You notice that we've got all real numbers that are in front of our bases, or our base of x, the variable, and we've got exponents that are non-negative integers. Now these two are out of order. That just means that it's not in general form, but it still represents a polynomial. Over here, we've got a negative exponent there. We can't have that. We've got a fraction here that also does not represent a polynomial. So those are some of the basics we'll see where it's not a polynomial. So a couple examples here. We just want to rewrite in general form if it's not already there, state the degree and our leading coefficient to classify those polynomials. So pause the video, give those a try, and we'll come back in a second. Okay, so we are going to start with this first example here, and I just switch a couple things, sorry. So we have our largest exponent here of 9. So 7x to the 9th is our first term, plus 4x cubed, plus 8x squared, plus 1.7x plus 6. Now remember that we can have a decimal as our coefficient, so they just have to be a real number. Typically we're going to see integers for those values, but you can have decimal or fraction there. It's just the exponent that must be an integer. So we've got it in order from largest exponent to smallest. So we've got a polynomial here. I just added in that classification as well, with a degree of 9 and a leading coefficient of 7. So you may also hear this called a 9th degree polynomial. The next example here, we have to put this 2x to the 10th term out in front, and now we have a trinomial with a degree of 10 and a leading coefficient of 2. Next example already has general form, so we've got a trinomial with degree 7 and leading coefficient of 2. And then our final example, we've got an exponent of 5, and we notice that that term is negative, so that negative has to come with. So now we have a trinomial with degree 5 and a leading coefficient of negative 8.